Claude Code was released in February 2025, and now that it supports the latest Opus 4 and Claude Sonnet 4 models, people have been absolutely raving about it. So the big question is it really that good? Maybe you're already using an AI tool like Cursor or Windsurf. And if you're already comfortable with your current setup, is switching over actually worth the effort? To find out, I decided to treat myself to the Claude Max plan and use it to build a brand new Flutter app that's been in my mind for some time. Now, the reason I needed this specific app is that recently I've got into calisthenics, which is a sport that will help me improve my strength and mobility. In fact, here's a quick clip of me attempting to do a frog stand. And to really nail this, I need to be able to hold the position for about 20 seconds. And as you can imagine, it's pretty hard to start and stop a timer with my hands in this position. So this is where my idea came from, a voice-activated timer app. This way, I can just say start or stop and control the timer completely hands-free. And as I record this video, I've almost completed version 1 of this app. And as you can see, it already features a complete stopwatch UI, along with the voice listening functionality, and even a settings screen, where I can update the timer format and change some other preferences. And while the app is fairly simple, I want to be clear. I personally made sure it's reliable and delivers a good user experience. And trust me when I say that the last thing I want to do is to ship a sloppy product built with a sloppy AI, without any proper testing and attention to detail. So in this video, I'm going to take you behind the scenes and show you exactly how I've been building this Flutter app using Claude Code. And you know what? I think this is the perfect app to really put Claude through its paces. Why? Because implementing this correctly means that we need to interact with the native platform. We'll need plugins like the speech-to-text package, and we'll have to handle all the necessary permissions. And it's going to be really interesting to see if Claude Code can handle both the UI and the underlying logic without going astray or making too many mistakes. So as part of this, I'll show you what my development workflow looks like. I'll give you some tips for using Claude Code effectively, and crucially, I'll highlight some features where Claude Code performed really well and others where it didn't. So by the end of this video, you'll have a good idea of what Claude Code can do and how to make the most of it. Alright, so let's get started and see how far we can get in building this app. And by the way, if you're keen to try Claude Code yourself, it's super easy. Just head over to this page and follow the setup instructions. And basically, all you need to do is to copy this command. And then you can navigate to your project directory and simply run Claude directly from your terminal. And you can do this from any terminal window, including the built-in terminal in Cursor, which is what I'm doing right here. In fact, this setup is great because it allows me to use Claude Code to build the app, but I can also easily jump in and make the changes manually from Cursor when Claude goes off track and I need to take control. Alright, so it looks like Cursor is asking us to pick a theme. So let's go ahead. And then we need to authenticate. And here we have a couple of options. The first one is to use a Claude account with a subscription. And this starts at $20 a month for the Pro plan and $100 a month for the Max plan, which gives us predictable pricing. Alternatively, we can use the Anthropic console account for pay-as-you-go API usage billing. Now, having used this for a little while, I'm just going to say that if you code daily and you can afford it, the $100 Max plan is absolutely worth it, because it gives you access to the latest Opus 4 model, which is incredibly powerful. But it can be quite expensive on a pay-as-you-go basis. So if you're using Claude Code often, that fixed price is a pretty sweet deal. So let me go ahead and sign in with my subscription, like this. And after a few more prompts, we are good to go and we can start using Claude. And from here, we can type / to see the list of available commands. For example, we can type /model to see the list of available models. And as you can see, the default mode gives us Opus 4 for up to 20% of usage limits, and then it uses Sonnet 4. So for this session, we'll go ahead with this default mode so we can see how far we can get with Opus 4. And now we can get started with our Flutter app. So as you can see, I've got a basic Flutter project open, which is completely empty and doesn't have any dependencies yet. And all it does right now is to show a simple hello world message. Now, before we even think about asking Claude to write some code, I want to give you my single most important piece of advice when using these tools. And that is always start by writing detailed and specific instructions that Claude can follow. This will dramatically increase the chances that Claude will actually do what you want. And more importantly, it also reduces the amount of refactoring that you'll have to do later on. So when you're starting a new project, a great way to do this is to create a file that clearly outlines your initial requirements. For this app, I created a specs folder, and inside it, I have this initial requirements.md file. And this is going to be our starting point. So let me quickly read this out. I want to build a voice-activated timer iOS app that I can use hands-free when performing my calisthenics exercises. The app should be built with Flutter and have the following features. Basic UI, a simple page app with a simple timer UI that shows the elapsed time, a start-stop button and reset button like on the iOS stopwatch app, and as a note, use a stopwatch object to keep track of the time. As for the voice mode, on app startup, the app should request our microphone and speakers access, and if the access is denied, the corresponding features will be disabled. When I say start, the app should immediately start the timer, and if the timer was already running and previously paused, continue from where it left off. When I say stop, the app should immediately stop the timer, and it should also play a beep sound when a voice command is recognized, such as start or stop. So these are all functional requirements telling us how the app should actually work. But we also have some other non-functional requirements. For example, with regards to theming, I want the app to only use dark mode. And also, theming should be done by setting the theme in the material app, rather than hard coding colors and sizes in the widgets themselves. As for the code style, I want to ensure proper separation of concerns by creating a suitable for the structure. We should also prefer small and composable widgets over large ones. And we should prefer using flex values over hard-coded sizes when creating widgets inside rows and columns, ensuring the UI adapts to various screen sizes. And as a note, use log from Dart developer rather than print or debug print for logging. So as you can see, these are some opinionated requirements about how I want Claude to handle things like theming, code style, and other non-functional aspects of the app. And without these, chances are that Claude will still write code that works, but again, if we are specific up front, we can avoid a lot of tedious refactoring later. And by the way, for bigger projects, I would probably go into even more detail here, maybe by clarifying my preferences for linting rules, dependency injection, writing tests, and so on. But for this specific project, I think this should be good enough to get us started, and we can always tweak things later if needed. And now that the requirements are clear, let's go back to our terminal, and from here we can run the /init command. And what this will do is to generate a Claude.md file, which will be automatically added as a context to every new Claude session. So you can think of this file as a permanent context about your project, and it's a good idea to keep it up to date as your project evolves. So as you can see, Claude is now analyzing our project, including the pubspec.yaml file. And while the operation is in progress, we can see how long it's taking and how many tokens it's used so far. And as you can see, it has detected that we have a file with the initial requirements. So at this stage, we can just wait. And it looks like it's asking us for permissions to read files to do with the cursor rules. And I suspect it's doing this to see if there are any other guidelines that are relevant to the project. And whenever Claude wants to run Unix commands such as this one, we can always choose whether we want to proceed or proceed without asking again, or perhaps stop here and tell Claude to do something differently. So for now, we're going to go ahead and say yes. And now it seems like it's asking us to look for hidden directories. So it seems to me that it's trying to do a bit too much. But let's say yes, just for this time, once again. Yeah, I don't know, for some reason it looks like it's trying to run many bash commands, which I think is a bit unnecessary for the purposes of getting started with the project setup. So I'm gonna say no instead, and then I'm going to say write the Claude.md file without running any other bash commands. Alright, so it looks like we have a Claude.md file over here, and I think at this point we can just read through it and see if everything is alright before approving it. So yeah, it contains a brief project overview. It managed to figure out some key requirements, probably from our initial requirements.md file. It also includes some instructions for running the app. These are quite generic and not very useful, to be honest. Then it's created some architecture guidelines, such as a proposed folder structure. And as part of this, it's proposing to create a features folder, a shared folder, and a core folder. And other than that, it's figured out some widget design principles, which are also borrowed from our MD file. And it's also imported some guidelines regarding code style. And it's also figured out that there are a couple of assets that are bundled in the project. And these assets are located here. And finally, it added a couple of platform-specific nodes. So yeah, there is something useful in this Claude.md file. I guess we can tweak it a little bit later, but for now, I'm gonna go ahead and say yes. And now that the command has completed, we can see that this file is actually created and added to our project. So as it stands, this file is a little bit generic and not very useful. However, remember that I've defined this initial requirements.md file, which is very specific to this project. So let's see if we can use it to generate an implementation plan for the project. And to do that, I'm going to press Shift-Tab twice. And what this will do is to enter plan mode. And this is a special mode that is used specifically for planning and reasoning about the project requirements, just like a senior developer would do. And within this mode, I'm going to enter this prompt. Think hard about how to implement all the requirements described in this file. Make a plan with all the proposed tasks and subtasks, focusing on the UI first. So let's go ahead and run this. So by doing this, Claude will generate a plan for us. So let me go ahead and open up this panel a bit more. And as we can see, Claude has generated this initial plan based on the requirements, and it's come up with a list of to-dos. And then it's created this very detailed plan. And if we take a closer look, we can see that Claude has broken down this plan into 4 phases, each with their own tasks and subtasks. And the best thing to do right now is to review this plan and see if there's anything we want to change. For example, I can see that in step 3, it's planning to create a timer display using this format. And it is only planning to create the timer page on step 6. And for some reason, it's decided to include the Baba's new font in step 7. And I'd like these things to happen earlier on, so I can test the UI right away. So at this stage, I'm gonna go ahead and tell Claude that I want to keep planning. And I'm going to ask it to make the following changes to the plan. Format the time as seconds.s, giving it an example. I also want to implement the timer display using a ticker, which will refresh with the screen's refresh rate. And I want to make sure that the Baba's new font setup happens as part of step 3. Then I'm telling it to create the timer page as part of step 3, so I can test the UI right away. And then update it again in step 4, so I can test the UI again after adding the buttons. And with regards to step 5, I want to declare the stopwatch directly inside the timer screen and passing it as an argument to the timer display, rather than using a change notifier, which is what Claude was proposing. And then I'm remarking that the overall plan should let me test the app manually at each step. So let's go ahead and press enter and see what Claude does with this. And as we can see, it's going to update the plan based on my feedback and make it iterative. So we're gonna just wait and let it do its work. And as we can see, here is the updated plan. And the new plan is following all my suggestions, making sure that the app is testable at every step. So overall, I'd say that I'm very happy with this plan. So what I'm going to do is to interrupt Claude, and then I'm going to press Shift-Tab to enter edit mode. And here I can tell Claude to write all the proposed tasks and subtasks to plan.md. And the reason for doing this is that this is our master plan, and since it's so valuable, we should write it to a file. Because this means that if we clear the Claude context or we start a completely new session, we can still refer to this file. And Claude will have all the information it needs to continue where it left off. So as we can see, the plan.md has been written into this file with all the details. And now we want to make sure that Claude always uses this as part of the context. So to do that, we can open the Claude.md file, and right at the top, I'm going to add a line here that says a complete plan for the project has been written to this file. Then we can save this file. And now that our plan is in place, we can open the source control tab, and then we can stash all the changes. And then we can use this button to generate a commit message. And then we can proceed with the commit. Alright, so our plan is in place and it's saved to version control. And this means that if we wanted, we could open a new terminal over here. and then we could start a new Claude session. And while this session doesn't have any knowledge of the previous chat history, it will automatically use Claude.md and the plan.md as the context, and this is what really matters. But for now, I think we can close this session, and instead we can continue working on the previous one. And by the way, what we can do at this stage is to run the compact command, which will clear the conversation history but keep a summary in the context. And this will help us save tokens without losing valuable information. So let's go ahead and run this. So yeah, this is a command that can take a little bit of time, but once again, the purpose here is that we can shrink everything that we said up until now and only retain the information that is most valuable. Alright, so it looks like this command has completed, and now comes the fun part, because we have a very good plan and we can start building the app. And it's going to be very interesting to see how Claude performs. So let me go ahead and say proceed with the plan, stop at each step so I can review. And as we can see, Claude is now starting to implement the voice timer app, following this list of to-dos. And as a first step, it's asking us to create the directories that were specified in the plan. So let's go ahead and proceed. And now that step 1 is complete, we can see that all these features were created. And now it's asking us if we want to proceed with step 2. So let's say yes and carry on. And now that this step has been completed, we can go ahead and review the new code. So over here, I can see the app thing, which is configured with a color scheme, as well as all these other themes. And we can also see that the main app has been updated to use this new theme. And by the way, if we want, we can open the source control tab, which allows us to see a side-by-side diff of what's changed on any file. So let me go back to the app theme file. And here I can see that there is a linter warning telling us that this property is deprecated. So I can go ahead and say fix the linter warning in, and then I can use the add symbol, and then I can start typing app theme, and Claude will automatically detect the correct file. So let me go ahead and press enter, and then enter again to confirm. So yeah, this add symbol is quite useful because it allows us to be very specific and tell Claude which file to look at. And this way of doing things is often faster and more token efficient compared to just saying fix the warning and having Claude scan the entire codebase. However, in this specific instance, the only way for Claude to fix this is to run Flutter analyze. So let's go ahead and proceed. And after running this command, Claude has figured out what the correct fix is. And then he wants to run Flutter analyze again to verify that the linter warning has been fixed. So let's go ahead and proceed. And as you can see, the error has now been fixed. Now, at this stage, I could spend a bit of time reviewing all this theming code and perhaps edit it by hand or give Claude some more instructions about what to change. But I think it only makes sense to do this once we have some UI that we can see. So overall, this is a good start. And if we wanted, we could go ahead and commit our changes to version control. But you know what? There is a smarter way to do that. In fact, if we scroll to the top of the file explorer, we can see this Claude commands folder. And inside it, I have this update plan commit file. This is a custom command that I've added to the project. And what it does is to update the plan.md file with the latest uncommitted changes, and then it stashes and commits all the latest changes with a short and clear commit message. And in order to run this command, you can simply type /update plan commit like this. So if we want, we can open the plan.md file and verify that Claude has added some check marks next to the tasks that have been completed. And over here, it's asking us to execute this command and commit the changes with this commit message. So let me go ahead and proceed. And at this stage, we can see that the commit has been made with all the latest changes. Now, if I'm honest, I don't really like that the checkmarks have only been added to the top level tasks, and I would prefer if individual subtasks also had their own checkboxes. So to ensure that, I'm gonna get back to the prompt and ask Claude to edit the plan.md, making sure that each individual subtask has its own checkbox, providing this as an example. So let's go ahead and run this. And as we can see, it appears that Claude has made the right changes, and it's asking us if we want to commit this change. So let's quickly review what's changed. And as we can see, all the subtasks that have already been completed have a ticked checkbox, while the others all have empty checkboxes. So this looks good, and we can go ahead and commit this change. Okay, so this is great progress. And the last trick that we have learned is that we can write our own custom project-specific commands to this folder and execute them from the prompt. And this is a very powerful feature because it means you can create automated workflows that execute multiple steps rather than performing the same steps by hand. In fact, this update plan commit command will be very handy for us later on, and we will keep using it as we iterate on the plan. Alright, so let's get back to our plan. And it looks like the next phase is to implement the core timer UI. So let's go ahead and type, continue with the next step in plan.md, stop when the UI is ready so I can review. And as we can see, Claude has figured out what the correct step is and is proceeding with the tasks in the to-do list. And as a first step, it decided to configure the Bubba's new font in the bubblespec.yaml file. So this all looks good. And now it looks like it's going to create the timer display widget. And it's also gone ahead and created the timer page. And finally, it's updated the main.dart file to ensure the timer page is used. And after making all these changes, it looks like it wants to run Flutter Analyze. So let me go ahead and let it do that. And this confirms that there are no problems with any deprecations. And as we can see, it's now telling us that the app is now testable. So let's go ahead and see if we can preview it on the simulator. So what I can do is to hot restart the app. And as I can see, it is now switched to dark theme and the timer display is visible as well. So this is good progress. And at this stage, I think it's a good idea to review all the latest changes. So let me quickly hide the terminal and then I can start with the timer display. And as we can see, this is a stateful widget, which takes the stopwatch object as an input. And here it's also using this ticker mixing and creating a ticker object as I requested in the original plan. And then inside init state, it creates the ticker. And with every callback, it makes a call to set state, which in turn will rebuild the UI. And then it starts the ticker and makes sure that it is disposed correctly. Then here we can find a helper function to format the time in the format that we have requested. And here we have the build method, which formats the time based on the value in the stopwatch, and then uses it to return a text object, which is using the correct font family. So as a first pass, this is very good, and it seems to satisfy all the requirements. Next, let's move on to the timer page. And as we can see, all this does is to create a stopwatch and pass it to the timer display, which is inserted inside the scaffold. And finally, the main.dart file uses the timer page as the home argument. So I would say that this is looking really good. And since I'm very happy with the latest code changes, I'm gonna go ahead and use our handy update plan commit command to ensure that the plan is updated and all the latest changes are committed to source control. And as a cherry on top, we get this nice commit message to confirm all the changes. So let's go ahead and proceed with this. So it looks like all the careful planning is starting to pay off because Claude has just one-shotted this part of the UI by following the requirements. So let's see if it's gonna do just as well with the next step, which is all about creating the timer controls. So here I can just repeat the same prompt, asking Claude to proceed with the next step. And then we can just sit back and let Claude do the work. And just as before, it's proceeding with the to-do list. And as a first step, it created the timer control button. And I don't know about you, but I think it's just a joy to watch it do its thing, you know? Like it seems to be doing all the right things. I don't have to do any work at this stage. Yeah, so if I open the shared folder, I can see that it's created the timer control button. And after updating the timer page, it's now asking to run Flutter Analyze. So let's go ahead with that. And it looks like it's found a private field that could be final. And check this out, it's suggesting that the linter is suggesting a change, but it's figured out that it can't be final since we will be modifying this in step 5. So this is quite a good amount of forward thinking that Claude is doing. And if we scroll down, we can see that now step 4 is complete. And it's telling us that we can test the UI. So let's go ahead and refresh. And there we go. We got a start and a reset button. But do they work? No, they don't work. And I think it's because this is part of step 5. But regardless, it's nice that it's being able to create these buttons. And all we have to do now is to go ahead and review the code. So let's start with the timer control button. And as we can see, it takes the onPressed callback along with a label and the background and foreground colors. And this is styled as an elevated button with a fixed size And I guess this is okay for now. We'll probably change it later. And here it just creates the text with the label that was passed in as an argument. So let's see if we can figure out how this code is used. So in the timer page, we can scroll down and we can see that after the timer display, we have this row with a start stop button and a reset button. So let me just quickly check where this was declared. And yeah, so it looks like it put this in the widgets folder. So yeah, I guess I'm okay with that. So yeah, this is actually a very good example of widget composition because Claude worked out that it can create a reusable timer control button. And then it's created two classes called start stop button and reset button, which make use of this reusable widget. So this is really good. Like, I think it's really following good code conventions and it's saving me a lot of refactoring that I would have had to do myself. So yeah, very happy with the changes. So once again, I can just go ahead and run my handy command to update the plan and commit the changes. And finally, we have this nice commit message telling us about all the latest changes. So let's go ahead and proceed with this. All right, so this is perfect. And step 4 has been completed with all these subtasks, and we can proceed with step 5. So once again, let's tell Claude to proceed with the next step. And I think it's going to be interesting to see if the state correctly propagates to all the widgets that have been created. So same as before, updating the to-do list. And ooh, that's an interesting one. It looks like I've just reached the limit of Opus 4, so we'll deal with this in a second. But for now, let's just continue and see if we can complete this task. So yeah, this looks good. And it looks like it figured out that the linter warning about is running is now gone because we are actually modifying this variable. So it's nice that it warned us about this. And it looks like step 5 is complete and we should be able to test the UI. So once again, let me hot restart the app. And now I can start the timer and yeah, look at that, it's working, it's working. I can stop the timer, start it again, so it continues from where it left off, stop again, reset, start. Yeah, this is good. So I think everything is working as intended. But as usual, I think it's always a good idea to check the changes. So let's see what's changed in the timer page. And as we can see, it didn't really have to change much because all the correct helper methods were already in place and were already called by the buttons. So really all I had to do here is to make a call to set state and tell it to stop or start the stopwatch depending on this state. So yeah, this looks good. I don't really have any complaints about this. So I think we can go ahead once again and just tell it to update the plan and commit the latest changes. So there we go. As usual, we get a nice commit message and yeah, we can just go ahead and save this. Cool, so this is good progress. And before we continue, we need to make a decision because earlier on, Claude told us that I reached the Opus 4 limit. And if I run model, I can see that I'm still on the default plan, but currently it is using Sonnet 4. And you know what? I've been so happy with Opus 4 that I'm not ready to switch to Sonnet 4 just yet. So I'm gonna tell Claude to switch to Opus 4 and continue using this model until I reach a hard limit. All right, so let's go ahead and review the plan. And as we can see, the next step is to refine the timer page layout. But you know what? I feel like this UI is too boring. And this means it's time to use one of my favorite Claude features. And that is the ability to work with images and screenshots. In fact, when I first started this project, I discovered a really nice interval timer app on the App Store, which looks like this. However, if we ask Claude to use this screenshot as a design, it's likely that it will attempt to add all the extra UI components that we don't need. And rather than let it generate a bunch of extra code and delete it later, I'm going to take a shortcut and use this screenshot instead, which is from the completed app and doesn't have any unnecessary UI. So here is what I'm going to do. I'm going to get back into Claude and then I'm going to type in this prompt. Using the provided screenshot as inspiration, update the styling and design of the timer display, start and stop button, reset button, and voice indicator widget. We'll use this later. Note the start and reset button should still appear side by side inside the row. Keep as much styling as possible in the top level theme, declaring constants with meaningful names in a separate file, rather than hard-coding values in the widgets themselves. So as you can see, I've been very specific about what I want here. And before submitting this, what I'm going to do is to take this screenshot and I'm going to drag it all the way here into the prompt. And then I'm gonna go ahead and execute this. So yeah, it looks like Claude is analyzing the screenshot and he's gonna attempt to match the styling. So yeah, as a first step, I can see that it's created an appconstant.dart file. And it looks like it kicked me into using Sonnet 4 again. So yeah, maybe we'll just have to do with that. So yeah, as it makes progress, I can see that it is creating a bunch of files over here. So yeah, I mean, it looks like this UI session is quite expensive in terms of tokens. So, and it's taking quite a little while. So fingers crossed that it will all look as desired. So yeah, it's finished generating the files. So let's go ahead and let it run Flutter Analyze. And so far it hasn't found any issues. And yeah, with a little bit of luck, it means that the app should now look just as in the screenshot. So let me pop up the screenshot open so I can see side by side. And then I can hot restart the app. And whoa, somehow it decided to, I mean, yeah, it's tried to match the design, but somehow it's put a gradient in here. I can see that the start and reset buttons are about the same size. However, I have a bottom overflow layout. So yeah, I think it's an okay attempt, but it could have done better. In any case, it seems that the UI is still working as intended. And at this stage, I could go ahead and just review the code. So yeah, let's go ahead and take a look at the changes. So first of all, app constants file. And at the top, we have this app colors class, which looks okay, because all these constants can be reused over and over inside the app. And then we have this app sizes class, which contains various constants for the timer display, the buttons, the voice indicator, and so on. And to be honest, I don't really like this, because some of these constants are very widget specific, and should probably not be in a global constants file. So perhaps it was a mistake to ask Claude to declare constants with meaningful names in a separate file, because this is not quite what I intended. So yeah, I think this code needs some changes, but for now, let's go ahead and review the other files. For example, here we have the app theme, and I can see that these changes are mainly to do with applying the styles and colors that we have defined in the app colors class. Then we have the timer display.dart, and the main change here is that the call to copy with has been removed. And this seems like a reasonable change, because the font is now defined inside the app theme. Then we can move to the timer page. And if we scroll down to the build method, we can see that we now have an app bar. However, it seems that the title is not using the correct font, and we can see this clearly in this comparison. Then we have this container with a linear gradient, which again is not what we want, right? And finally, we have this column with some expanded widgets that are used to control the flex factor of the child widgets. And overall, this layout seems to be causing a bottom overflow issue. So yeah, I'd say that some parts of this code are okay, but others need some changes. But let's carry on and open the circular timer button. And as we can see, this seems to match the correct design. And overall, I think this code looks reasonable and might only need some small tweaks. And both this reset button and start stop button classes now use the new circular timer button rather than the old timer control button. So I don't have any remarks here. And finally, we have a voice indicator widget, which is used to implement this custom UI at the bottom. And I think this code is a good starting point. But overall, this is the first time in this coding session that I've not been too happy with the code that Claude has generated. And to be honest, I think perhaps my prompt wasn't clear enough about certain things. So what can I do to improve this? Well, at this point I have a decision to make. I can either refactor all this code and make the UI look as intended, either manually or with some help from Claude, or I can discard all the changes and get back to the previous state and try again when Opus 4 is available again. And since my goal is to really leverage the best of Claude Code and see if you can write the correct code from a single prompt, I'm going to go with the second option. So from the source control tab, I'm going to go ahead and discard all the changes. And then I can go ahead and hot reload, and I can verify that we are back to the old UI. And by the way, if I open the terminal, I can see this warning telling me that the IDE is disconnected. And this has been here for a little while, and I'd like to fix this. So to do this, I'm going to go ahead and exit my current Claude session. And then I'm going to start a new one, like this. And just to be clear, when we start a new session, all the previous chat history is no longer available as context. However, this shouldn't be a problem because we have this plan.md file, which represents our permanent context. All right, so let's get back to the terminal. And before entering the next prompt, I'm going to go ahead and add a new folder called constant over here. And then what I'm going to do is to take this app colors file and drop it in here. And as you can see, this file defines 3 colors that I want to use in the app. So my goal here is to tell Claude what colors to use rather than trying to guess it from the screenshot. So let me go ahead and commit this file like this. And now I can enter my updated prompt, which looks like this. Using the updated screenshot as inspiration, update the styling and design of the timer display, start stop button, reset button, and voice indicator widget. So this is the same as the previous prompt. However, this is what's changed. Keep as much styling as possible in the top level theme and ensure all text widgets use the Baba's new font. When styling the UI, use the colors in, and here I'm going to reference the app colors file that I've just added. And just as I did before, I need to attach this screenshot as reference, like this. So let's go ahead and execute this prompt. And by the way, this prompt is now executing on Opus 4, so it should be interesting to see how much difference we get. So as we can see, Claude is now exploring some of the existing files in the project. Then it's making sure that it's using the correct font. And here it's asking if we want to make some changes to the app.theme.dart file. So let's review them. And as you can see, it's set the font family over here. Then it's used the app colors that we have defined. And crucially, it's remembered to set the title text style inside the app bar theme. And it's also done the same for the text style inside the elevated button theme. And the same here and here as well. And so on. So overall, it looks like it's set the font family to every single text style in the app theme. And while this may be overkill, it should at least guarantee that the correct font is used everywhere. So I'm gonna go ahead and proceed with these changes. And as a next step, it's asking us to do a small change by removing this background from the color scheme. And I think this is reasonable, so I'm gonna go ahead with this. And hopefully now it's going to update the timer display using the correct styling. So yeah, we have some more changes to review in the timer display. And I guess I'm just gonna go ahead with that, like this. And while Claude continues with the rest of the work, I can already restart the app. And I can see that this style has been updated correctly. And it looks like we have another request to add this line, so I'm gonna go ahead with this. And here is another one-line change. So yeah, it looks like Claude is asking us to review every change one by one, even for one-line changes. And to be honest, I'd rather review them all together when the UI is ready. So here I'm going to choose option 2, so it won't ask me again. And yeah, so as a next step, it's going to update the start and stop button. And now it's made some changes. And while it continues to work, I can restart the app and I can see that the start button has been updated. And now the reset button has been updated as well. So yeah, I think we're just gonna have to wait until everything is completed. And after making all the changes, it's asking us to run Flutter Analyze. So let's go ahead with that. And it looks like it's found and fixed an analyzer issue. So let's run this again. And it looks like we should be ready to go. So let's hot restart once again. And there we go. So the result is much better than what we had before. However, some tweaks are still needed. For example, we are missing the start and reset labels under the buttons. And this voice indicator should use a stadium border perhaps rather than rounded corners. And maybe we could make this font bigger. But overall, I'm happy that the UI is already much better than what we got in our previous attempt. And if we spend some time reviewing these files, we can see that the correct colors are used. And in the timer page widget, we ended up with a reasonable layout. So at this stage, we can already commit these changes. And we can do that by using our handy update plan commit command. So yeah, it looks like Claude has made some changes to the plan. So let's go ahead and review them. And as we can see, step 6 has been revisited and expanded by adding all these items. So at this stage, we can proceed and stage our changes. And then we can also go ahead and approve this commit. And now that we saved our changes, let's see if we can make some of the tweaks that we were talking about. And this time I'm going to do this by adding some more to-dos to the plan. So let me go ahead and copy some to-dos and paste them in here. And as part of these changes, I want to repurpose the timer control button to match the new button file. And I want to make sure that these buttons include the start, stop, and reset labels. I want to use a stadium border inside the voice indicator, make the font bigger in the timer display, and adjust the flex factors. So I can save this plan. And now I can get back to my prompt and I can say proceed with the missing to-dos in step 6 in the plan. Stop when the UI is ready to test so I can review. So if we open this up a little bit, we can see that it's now tackling all the different to-dos, and we can just wait until it completes all the to-dos one by one. Then I'm gonna go ahead and let it run Flutter Analyze, and while it's doing that, I'm going to restart the app and see how it looks. And yeah, overall, I think this is much better, and we're now really starting to get pretty close to the intended layout. And we can also quickly verify that the timer still works as intended. So overall, I think the resulting UI is not perfect, but good enough. And all we had to do was to provide a screenshot of the final UI and prompt code without the necessary details. And up until now, we barely had to write any code at all. And since Claude has produced some reasonably good code, we could go ahead and make the remaining changes by hand. So yeah, I think this is all pretty impressive. So we can go ahead and tell Claude to commit the changes. And here we can go ahead and proceed. And then we can approve the commit message. Cool. So next up, I think it's time to take a break from UI work and move on to phase 3, which is all about adding the voice features. So before we start this new piece of work, I think we can go ahead and clear the current session and start a new one, since this will allow us to save some tokens. And then we can quickly review the plan. And as you can see, the first step is to set up the iOS permissions. And actually, before adding the microphone permissions to the info.plist file, we should also add the permission handler package. So let me add this to the plan, and then I can get back to the prompt, and I can tell Claude to continue with the next step in plan.md. So let's go ahead, and while Claude is doing his work, what I'm going to do is to stop the app, and I'm also going to delete it. This way I can simulate what happens with the permission flow when the app is first installed. Alright, so we can see that Claude has now added the permission handler package, and also it's added the microphone usage description in the info.plist file, which is a required step. And now it's going to go ahead and add the permission request flow on app startup. So it looks like in order to do this, it's created a permission service.dart file. And after making all the changes, it's asking us to get the packages. And you know what? We actually don't need to run this command, because the IDE automatically does it when the abstract.yaml file is saved. So what I'm going to do is to tell Claude to do something different. And the way I'm going to tell it is to use this hash key to add a memory. And the memory is going to be no need to run flutter pub-get after installing packages. The IDE does this automatically. And when I do this, Claude is asking me where I want to store this memory, giving us these 3 options. So let me go ahead and add this to the Claude.md file. And from now on, Claude will remember this. So let's go ahead and continue with the plan. Actually, let's stop there, because I didn't want it to implement voice recognition. So at this stage, I think we should just review the changes that it's made. So as you can see, we have a permission service class, which is using the permission handler package. And inside it, we have this method that requests the microphone permission. And then it uses this switch statement to handle the different permission states. And down below, we also have this hasMicrophonePermission method, which is used to check the permission status, but without actually requesting it. And note how Claude also decided to handle exceptions by logging them to the console. And this is not really robust, and before going to production, I would probably want to make some changes. But for now, this isn't too bad, and the only change I want to make is to replace this switch statement with the same statement that we have down here. So I'm going to copy this, and I'm going to replace it over here, like this. And yeah, overall, it's just quicker to do this by hand rather than asking Claude to do it. Next, let's move on to the main.dart file. And as we can see, Claude has decided to turn the main app into a stateful widget. and request the permission inside init state. However, I don't really like this because this is a single page app, and for now I'd rather have all this code inside the timer page, since this will make it easier to update the UI if needed. So let's see if Claude can help with this. So here in the prompt, I'm going to say this is a single page app, revert the latest changes to main.dart, and move the permission request to the init state method of the timer page widget, along with the corresponding state. So let's go ahead. And as we can see, Claude has reverted the changes to the main file. And now it's added them to the timer page, just like I requested. And we can see them right here. Alright, so I think this is a good time to test our app once again. So let me go ahead and run it on my iPhone simulator. And while I wait for this, I can also open the debug console and see if there are any errors. And as you can see, the app is being installed. However, it looks like the microphone permission status is permanently denied. So what could be causing this? And why did we not see a native microphone permission dialog? Well, as far as I can see, the code is correct, because in the timer page we request the permissions from a method that is called from init state, and in the permission service we call the underlying API to request the permission. So we should definitely see a native dialog when this line is executed. So let's see if Claude can help us with this. So back on the prompt, I'm going to enter, upon first app startup, the app doesn't show the native microphone request. This is not a problem in the Dart code. Is some more platform specific configuration needed? So let me go ahead and run this. And by the way, I'm running this prompt from a new session because my cursor IDE crashed while I was away. But hopefully Claude will still figure this out thanks to our plan. And as we can see, here it's trying to read the iPhone deployment target from the settings. However, I don't think this is quite the right solution. So I'm going to choose no as an option, and instead I'm going to be a bit more specific and say check for iOS setup instructions in the README of the permission handler package. And this gives me the chance to use fetch mode, which is a feature that lets Claude browse the web. So let me go ahead and say yes to this request. And as you can see, it seems that it's figured it out. So it says that we need to add the microphone permission configuration to the iOS pod file. And here it's going to go ahead and update it. So as part of this, it decided that it wants to add modular headers. So I think I can go ahead with that. And it's also added a bit configuration by setting permission microphone equal to 1. Now, to be fair, I'm not too familiar with this syntax, so I might want to double check this on the permission handler package. And as you can see in the setup section under iOS, we find some instructions that tell us to do exactly this for each permission that we need to use, such as the microphone. So yeah, it looks like this is the right change to make. So let me go ahead and make this change. And then we can go ahead and perform pod install. And since we have made this change to the pod file, I think it's fair enough if we stop the application and then we can run our app again. So let me get back to the debug console. And once the application starts, we can see that finally we get the native permission dialog. And here we can proceed and click allow. And we also get a confirmation that the permission status is now granted. Alright, so this is great progress. And since we fixed the issue, we can run our handy update plan commit command like this. And as we can see, Claude has now expanded step 7 with all these additional TODOs. So we can confirm this. And then we can stage all the changes. And we can approve this commit message as well. Alright, so let's get back to our plan.md. And as a next step, we can see that it's time to prepare for the voice recognition mode. But before proceeding to this step, I think there are a couple more things that we need to do as part of step 7. So let me go ahead and add some TODOs. So what I'm saying here is that we need to add the speech recognition permission to the info.plist and pod file. Then I want to request both the microphone and speech recognition permissions together in the permission service and only return true if they are both granted. And if the permissions are denied, show an alert dialog with instructions along with cancel and open settings buttons. So as you can see, these to-dos are very specific and should help us get the results we want. So let's save this file, and then we can tell Claude to proceed with the missing to-dos in step 7 of the plan. So as a first step, we can see that Claude has updated the info.plist file, so let's confirm this. Then it's updated the pod file, So this also looks good. And now it's going to do some code changes. And now it's asking us if we want to edit the permission service. So let's go ahead and review these changes. So as we can see, Claude has renamed this method to request voice permissions. And inside it is declared a list, which contains these two permissions. And then it's using this method to request them at the same time. And down here, it's checking if they are both granted by looking at the status of each individual permission. So my guess is that this status is a map that can be accessed by key using this syntax. And this is not something that I was aware of, so I guess it's always good to learn something new. So if we scroll down, we can see that this method has also been renamed, and it follows a similar logic, like this. And we can see that Claude has also kept the old methods for backward compatibility. So I guess we'll remove these methods shortly, but for now I can go ahead and approve these changes. Now the last step in our to-do list is to add this alert dialog for permission denials. And it looks like Claude is trying to add material.dart inside the permission service, and I guess its next step will be to add the alert dialog code to this file. And I think this is not a good idea, because this is a service class, and I don't want to add any UI code to it. So here I'm going to press escape, and instead I'm going to say show the alert dialog in the timer page after checking if the permissions are denied. And hopefully this will steer Claude in the right direction. So yeah, it looks like Claude has made some changes to the timer page, so let's review them. So here is the updated call to request voice permissions. And if has permissions is false, then we show the permission denied dialog, which is defined over here. So this seems like a step in the right direction. And I'm going to go ahead and approve these changes. And then I'm going to let Claude finish its job. And here it looks like Claude needs to add the permission handler to this page, so I guess that's okay. And then it's decided that it wants to run pod install after adding the speech recognition permission, so let's go ahead as well. And it looks like all the to-do have been completed. And since we made some changes to the pod file, I'm going to stop the application once again, and then I'm going to start it from scratch. And what I would expect to happen at this stage is to see the speech recognition permission, but not the microphone permission, because we have already granted that previously. So let me switch over to the debug console. And now the app has started, and as expected, it's asking us for speech recognition. And in order to test this properly, I'm going to click Don't Allow on this permission. And as we can see, we now get the permission denied dialog. And while I'm happy with the contents of this dialog, the style doesn't quite match the native platform look. And I think it would be best if we could use a Cupertino alert dialog instead. And this is something that I've done so many times in the past that I already have a helper file that I can use. So let me go ahead and open the file explorer. And then I'm going to take my file, which is called show alert dialog, and I'm going to drop it inside the widgets folder, like this. And under the hood, this file contains a show alert dialog helper function, which uses the built-in show adapted dialog API. And now that I have this file, I can go back to the terminal, and I can tell Claude to update the show permission denied dialog to use the show alert dialog function in @show alert dialog, like this. So let me go ahead and run this. And after reading the file, Claude decided to import it in the timer page, so let's go ahead. And just as I asked, it's replaced the old call with the show alert dialog by passing all the correct arguments. And it's also figured out that if the result is true, then it should open the app settings. So this looks good, and I can approve this change. And now that we are using the correct dialog, we should be able to hot restart the application. And as soon as we do this, we can see that we get a nice iOS looking permission required dialog. And if we click on Open Settings, we are taken to the iOS system settings for this app, where we can enable speech recognition. Alright, so it looks like everything is working as intended. And since I changed the permissions from the iOS settings, the app has been killed. So I need to go ahead and start it again. And while I wait for this, I can run the update plan commit command. And as usual, Claude will update the plan.md file. And I can see that all the to-dos inside this step have been completed. So let me go ahead and approve this change. And then I can approve this command. And I can confirm that I want to commit all these changes. All right, so this is great progress. And now we can focus on the next step, which is about implementing voice recognition. Now, as you can see, this step is only composed of 4 items. And to be honest, I expect that it might be quite complex to implement this feature correctly. And while Claude is quite capable, I doubt that it will implement the right thing without some extra details. So at this stage, I think it's a good idea to create a new document that explains how this feature should work. This way, we can use plan mode to figure out a possible implementation strategy before writing any code. Now, in the interest of time, I've already prepared a document with the requirements. So what I'm going to do is to take this document and drag it into the project inside the specs folder, like this. And now I can read it to you. So these are the requirements of the voice recognition feature. App startup. Request microphone and speech recognition permissions and show a dialog if the user denies the permission. This is already implemented. If the permissions are granted, initialize the voice recognition service. If the initialization is successful, then start a listening loop. Listening loop. Start listening for voice commands. Listen continuously until a command is recognized, such as start or stop. As soon as the command is recognized, stop listening, then process the command by starting or stopping the timer using the existing methods in the timer page, then play a beep sound. And for now, we're just going to add a comment with a to-do, because this will be implemented later on. Then start a listening loop again. Make sure to implement the listening loop by creating the appropriate methods and calling them recursively as needed. With regards to error handling, if any errors occur during initialization, recover gracefully by attempting the initialization again, recursive. And the same thing should happen for the listening loop. Implementation guidelines. Propose a solution that is simple, uses as little local state as possible, and keeps the API calls and UI code separate. So as you can see, this document is quite detailed and explains what the feature should do and includes a bit of guidance about how to implement it. And hopefully Claude will be able to take this and come up with a reasonable plan. So let me get back to the terminal. And since we are about to start a new feature, we can clear all the previous context. And then we can press Shift-Tab twice to enter plan mode. And here we can say, make a plan for how to implement the feature described in specs/voicerecognition.md. So let's run this and see what Claude comes up with. And just so you know, I've written this voice recognition document just a minute ago, and this is the first time I'm using it in this project. In other words, all I'm trying to do is to iterate using plan mode and see if Claude can come up with a good solution. So as you can see, Claude is exploring the current code base, and this is taking a little bit of time. And now it looks like it's come up with a plan. And this is broken down into 3 phases, including dependencies and services, integration with the timer, and audio feedback. So at first sight, this looks okay. However, I don't see any mentions of the voice recognition document that I have given as context. So I just want to make sure that Claude takes this into account. So I'm going to say, make sure the plan takes specs voice recognition into account. So yeah, it looks like this time it's read a whole bunch of files, and now it's created an updated plan. And if we go ahead and read it, we can see that this time is following my specifications, and as part of the implementation strategy, it's planning to add the speech recognition package. Then it's going to create a voice command service, which takes into account my instructions with regards to the initialization and the listening loop. And it's also considering error handling and minimal state. And then it's going to integrate with the timer page by initializing the command service after the permissions are granted, and by connecting everything up. And it's also proposing to update the voice indicator to accept the listening state from the timer page and show appropriate visual feedback. And here is a summary of the architecture principles that I have suggested. So yeah, I think this all looks very good. And since this is quite valuable work, I'm going to ask Claude to write the proposed plan to a file. So let me enter edit mode, and then I can say write the proposed plan to specs/voice-recognition-plan.md. So yeah, as you can see, we now have my original file that contains the requirements, as well as the voice recognition plan. which was generated by Claude. And now that we have this, I'm also going to tell Claude to update the remaining steps in plan.md with all the to-dos from the updated plan. And this will help us keep things in check. In fact, if we open the plan.md file now, we can see that we have far more details inside this tab. And I think this will really help us. And before we continue, I think it's also a good idea to update the plan and commit. So yeah, let's go ahead and proceed with this, and proceed with the commit message as well. Okay, so I think we are in a great position, and we have all the context needed to implement this feature. So we can go ahead and tell Claude to proceed with the next step in plan.md and ask for confirmation after making changes to each file. So let's see what Claude can come up with. And as a first step, it's adding the speech-to-text package. So this seems reasonable, and we can let it proceed with the next step. So yeah, I can see it's using quite a bit of tokens, and it's written this file. So let's go ahead and take a look at it. Alright, so let's start from the top. And the first thing we notice is that we have some errors because we are using void callback without importing it. But that's okay, because we can fix this immediately by importing Dart UI, like this. And we can also do the same and import material.dart. In fact, that's the only import that we need, like this. And now let's take a closer look. So at the top, we declare this speech-to-text object, which is imported from the package. And as you can see, we have two state variables, isListening and isInitialize. And to be honest, I don't really like this, because my intention was to store these variables in the timer page, since they'll be used to update the UI. And in my opinion, this class should be completely stateless. Then we can see that we have this method called setCallbacks, which is not really idiomatic Dart code, and I suspect we'll have to change this. But for now, let's carry on. Then we find the initialize method. And what this does is to call the underlying speech-to-text initialize method, which takes onStatus and onError callbacks. Then if everything goes well, it starts the listening loop. Otherwise, it waits for 2 seconds and then it tries again. And the same thing happens if an exception occurred. And again, I don't like this. And I think it would be better to move all this logic to the timer page. And also, I don't like that we have calls to future.delayed with an arbitrary delay. And in principle, I don't see any reason why we shouldn't be able to retry right away. So let's go ahead and move to the start listening loop. And the most important part of this code is that we have a call to speech-to-text.listen, which takes an onResult callback, which in turn is handled by this onSpeechResult method that is defined down here. However, I don't like this method because it contains all this duplicate logic for each recognized command. And this isn't going to scale if we add more commands later on. And if we scroll down, we find a bunch of other helper methods and callbacks that are used to update the state, and also call methods such as restart listening and start listening loop. So yeah, if I'm honest, this is not a good start. And to fix this, I'm going to drop in some suggestions. So let me get back to Claude Code. And since I have many suggestions to make, I'm gonna go ahead and write them into a document inside the specs folder. So this is going to be called voice recognition improvement. And here I'm going to add all these suggestions. So this is what I want. I want the voice command service to be completely stateless and any state variables should be moved to the timer page. I want to remove the setCallbacks method, and instead I'd like the onStatus and onError function callbacks to be passed as arguments directly to the initialize method. I want to remove all calls to future.delayed. I want to define an enumeration with the start and stop commands. I also want to rename this method to become public and fix the deprecation warnings inside it. And then I want to update the start listening method to return a future of timer command. And I also want to remove this onSpeechResult helper method and re-implement it in line. And overall, I just want a better API for interacting with this service. So I'm suggesting to use a completer that completes when a command is recognized inside the onResult callback. And I also want to remove all the other helper methods. And finally, we should ensure that speech-to-text.stop is called before the completer completes and a value is returned from start listening. So yeah, let me go ahead and save this file. And then I'm gonna get back to Claude and say, think hard and make the changes listed in specs voice recognition improvement, like this. So let's see if this is enough to steer Claude in the right direction. And while I wait, I'm going to get back to the voice command service. So yeah, as you can see, Claude is showing us a bunch of green check marks. So hopefully it's done the right thing. But yeah, it's time to go ahead and review the updated file. Alright, so as you can see, the voice command service is much simpler now. In fact, the initialize method is now just a simple wrapper for this call, and also the start listening method is much more streamlined. And all it does is to call speech-to-text.listen, and when it detects a result, it extracts the recognized words, and then it checks if the words contain start or stop, and if that's the case, it stops listening, and then it calls the completer with the correct enumeration value, like this. And while this code could still be improved, it's already something we could work with. And by the way, since this class is stateless, I'm going to go ahead and make all these methods static, like this. And this object can become static as well, like this. Alright, so this is good progress, and at this stage, we could attempt to move to the next step and integrate this class into the timer page. And that's exactly what I'm going to do. So let's go ahead with this. So yeah, as you can see, it's making some changes already. And yeah, we can just let it do its own thing. Cool, so it looks like Claude has completed this task. And here is a fairly convincing summary of what it ought to do. But is this what is actually happening? Well, let's go ahead and find out by reviewing the timer page. Okay, so here I can open the source control tab and click on this file to view the side-by-side diff. And then we can start scrolling down. So as you can see, here we have some updated state variables. And then we can see that inside the request permissions method, we call the initialize voice service if we have the correct permissions. And then we can go down to this method, and we can see that inside it, it calls voice command service.initialize, passing these two callbacks that are defined below. And then if it all goes well, it calls start voice listening. Or if we get an exception, it calls itself again recursively. And if we scroll down, we can see that the onVoice status simply logs the status and updates the state, and the onVoice error callback also updates the state, and it also calls start voice listening. Now, to be honest, I'm not too sure if this is the right thing to do, because if the initialization fails, it's unlikely that attempting to start listening again will work. But for now, let's carry on and review this method. So here we return early if these conditions are not satisfied. And then we have this code to voice command service.start listening, which will continue to listen until we say start or stop, and then it will return a command. And here we use a switch statement to check this command and use it to toggle the timer depending on the local state. And once we are done, we call start voice listening again recursively, ensuring that the listening loop continues. So overall, this code looks very reasonable, and while there are some edge cases that we might need to check, we can already take it for a spin. And by the way, if we want to test speech recognition properly, we need to do it on a real device and not on a simulator. So let me go ahead and make sure I've selected my real device from this list. And then I can try to run the app, and also I'm going to open the debug console, like this. And I'm also going to bring my device preview up here. And now I just need to wait until the app is up and running. Okay, so it looks like the app is starting. And here I can tap on allow to grant all the required permissions, like this. And now we can see if speech recognition is working. And if I go ahead and inspect the logs, I can see that the voice command service was initialized successfully, and then it transitioned to the available and listening states. But it looks like the app recognized this as a word, and then the voice status was set to done, but I would have expected it to start listening again after that. And this means that if I say start or stop, the app is not recognizing it, and it looks like the listening loop got stuck because it's not logging anything else to the console. But you know what? Let's try to hot restart and give it another chance. Whoops, this is something that sometimes happens, but bear with me. So here it goes. Start. Ooh, look at that, it's working. Stop. Start. Stop. Pretty good, I'm quite happy with that. So it looks like this time it's working, but it seems that just by speaking, I got it to recognize this sentence, and the voice status has got back to done again. So if I say start, stop, then it looks like we're stuck again. Alright, so it looks like the app is working some of the time, but if we speak something that doesn't match the start or stop command, then it gets stuck and it no longer works. So what can we do about it? Well, to be honest, what we have here is a bug that can only be fixed by making changes and then testing manually to see if they work. And while we can ask Claude to help us, I don't expect that this is going to be an easy fix. And in fact, it did take me a fair amount of trial and error to get this working on the production app. So what we have here is a prototype that kind of works, but it needs some extra care before it becomes production ready. And my goal here is not to show you how to go from zero to production, because that will take a little bit too long. But still, it's already quite impressive that we managed to get this far without writing any code. And if we really wanted, I don't see any reason why we couldn't go even further. So at this stage, I think it's a good time to commit all the latest changes. So let me go ahead and open the terminal. And by the way, earlier on, my cursor ID crashed, so I had to start a new Claude session. And the good news is that all the important files were already generated, so I can just go ahead and run the update plan commit command. So yeah, we can just let Claude do its job. And here we can approve the latest changes to the plan.md. And now we can proceed by adding the changes to Git. And we can also approve this commit message, like this. All right, so this is good progress. All right, so looking at our plan.md, we've actually made a ton of progress on this app. We've gone from the initial project setup through to the core UI implementation, and even integrated complex voice features with permission handling and the voice recognition service. And for these steps, we barely had to write any code ourselves. Now, there are still a few tasks left on this plan, like adding a beep sound when a command is recognized, as well as cleaning up the UI, and perhaps we could do a complete audit of all the code that we have generated so far. And of course, we could keep using Claude Code for this, but to be honest, the drill is always the same. Defining the task, prompting Claude, reviewing the code, and iterating. And I think it would be a bit repetitive to go through all these steps, so I'm not going to cover them on this video. Instead, I want to jump ahead and show you some features from the actual production version of this app, which I've already launched on the App Store. And by doing this, I can show you some other features where I've been able to extract a lot of value from Claude Code. For example, notice how the voice indicator has this nice animated border that circles around it while listening. And creating a custom UI like this, especially with animations, usually takes a bit of effort. But thanks to Claude Code, all I did was to show it an example of a similar animated button from a website and gave it a single prompt describing what I wanted. And from that, Claude Code was able to generate this entire stadium border painter class, along with all the animation logic, and this saved me a lot of time. So if you need custom UI with animations, try giving Claude an example and describing the desired effect, and let it do the heavy lifting for you. And by the way, while I was working on this voice indicator, I also decided to add this info button, which brings up an action sheet with an explanation of all the supported commands. And again, all it took was a single prompt, and Claude nailed it on the first try. But you know what? There is one feature where Claude really did an amazing job. And that is the ability to show different time formats, which you can see over here. And the way this works is that I can select a different timer format, and then this gets updated on the stopwatch page, like this. And I can go back here and change it again if I want, like this. And the way this works is that I have this enumeration called time format that defines 3 different formats. And this enumeration has a method called format time, which is used for showing the timer UI. But it also has a method called format time for speech, which is used by a text-to-speech module. And the way this works is that when I want, I can say time
4.8 seconds.
And the app says it out loud. And to deliver a better experience, I wanted to generate different speech patterns for each format. And all I had to do was to write some examples about how certain times had to be formatted and spoken. And Claude was able to generate all this code for me. And to make sure this code was correct, I asked it to generate a test suite full of unit tests covering all the different edge cases. And since Claude is agentic, it was also able to run the tests, identify any failures, and fix a couple of edge cases. So overall, I've been extremely impressed by just how much value Claude Code was able to deliver. And as a result, I've been able to build this app from scratch and ship it in just 3 days. And even though I've only been using Claude Code for a few weeks, it's already helping me deliver quality apps much faster. Because my job is transitioning from writing code to writing requirements and reviewing code. Alright, so I think we covered a lot of ground, and this is a good time to highlight some key lessons and share some tips about how to use Claude Code effectively. So the first one is to be specific and write detailed requirements. And this should describe in detail what your app should do and how it should behave. And you should also include non-functional requirements, such as your desired code style. And remember that the more precise you are, the better Claude will understand your intent. The second tip is to use planning to structure your workflow. So break down the project into smaller tasks using Claude plan mode. Then keep the plan updated and follow it step by step, reviewing and committing the changes after each task to maintain a working state, and this way it's easy to revert your changes if needed. And as a bonus, you can ask Claude to ensure that your app is testable at each step. And my next tip is to actively guide and review code ruthlessly. So don't blindly accept Claude's output. Read the code, make sure you understand it, and be critical. And if it's not what you want, be prepared to discard the changes and provide more specific guidance or a better prompt. For example, when Claude created the first draft of the voice command service, there were many things that I didn't agree with, so I spent some time coming up with this list of actionable suggestions, and then I told Claude to follow them. And I was only able to make these suggestions because I had a clear understanding of what I wanted to achieve, and how I wanted the code to look like. And the reality is that there are times when you need to articulate your requirements with this level of detail. Otherwise, you end up with code that doesn't work properly and gets messy really fast. And even though this is hard to do, it is worth it, because generating code is cheap, but maintaining bad code is expensive. But once again, if you are specific, provide active guidance, and review the code thoroughly, then Claude Code will become a real skill multiplier. Because it can handle boilerplate, figure out API usage from the documentation, generate complex logic and tests, and write most of the code for you, and honestly, it feels quite magical. In fact, following these lessons makes all the difference between vibe coding, which only produces sloppy products, and AI-assisted software development, which helps you build robust and maintainable apps. And I don't know about you, but I'd much rather be in the second category. Alright, so we have now covered a lot of ground and seen how Claude Code can help build apps faster, and as a result, we managed to get a working prototype. However, I hope you'll agree that the app I built during this video isn't truly production ready. And the final app that I published includes a lot more polish and crucial features such as analytics, user feedback, and error monitoring. And to be honest, many of these production-ready features are boilerplate or patterns that I've already battle-tested in my other apps. And for those, it was often quicker to copy-paste and adapt my existing code rather than asking Claude to implement it from scratch. So while Claude Code is amazing for building core features and tackling new problems, don't hesitate to reuse your own proven code, which might include monitoring, utility classes, and so on. And perhaps you could even look into writing custom Claude commands so you can more easily integrate your pre-existing code into your new apps. And ultimately, Claude Code can do a lot of the heavy lifting for you and really speed up development. So my advice is to give it a go. And if you're a professional developer and you can afford it, the Max plan is absolutely worth the investment. And Opus 4 is a big step forward compared to the other models. Now, you may be thinking, what about Cursor? Should you still use it, or is it better to use Claude Code for everything? Well, as we have seen in this video, I've been using Claude Code for planning, generating code, and tackling complex tasks. With that said, I still find Cursor useful for tab auto-completion and for making small inline changes. So at the moment, I'm still paying for both tools, and this way I can use them both to my advantage. On a final note, I'd like to say that on this video, we have only scratched the surface of what Claude Code can do, and if you want to learn more, you can find some useful links in the description below. Alright, so thanks for watching, and let me know in the comments if you tried Claude Code and you have any questions. And if you found this video helpful, please give it a like and subscribe for more Flutter and AI related content. And I'll see you on the next one.